Hi, my name is Imogen Knight and I'm the Biopharmaceutical Product Specialist here at Pion. Today I'm going to give you a short demo of our Pion SCISSOR. So let's get started. This is the SCISSOR system. By its side we have the Gilson autosampler, which allows us to take aliquots of the chamber buffer at time intervals during the assay, which we can take for offline analysis to quantify the drug release per unit of time. Here we have the chamber setup in the system. When we remove the chamber, we can see the heater plate as well as the LED blocks. We currently have two different chamber sizes. The larger 300ml chamber is shown here for high concentration formulations such as monoclonal antibodies. We then have the 50ml chamber, which is more suited to low concentration formulations. The chamber itself is filled with our bicarbonate buffer, which emulates our interstitial fluid. Looking at the system more closely, here we have our customized dialysis cartridge, which simulates our subcutaneous environment. It has customized dialysis membranes on the front and back of the cartridge, which allow for diffusion of the formulation out of the cartridge over time. The two other sides of the cartridge are clear to allow the LEDs in the system to read through the cartridge during the experiment in order to monitor the physical stability of the formulation upon injection. To start an experiment, we fill our cartridge with our artificial extracellular matrix. We then fill the cartridge to the brim with the matrix and place the cap on to seal inside. The cartridge is then slotted into the cartridge holder like so. The cartridge holder is then put onto the chamber lid. And the chamber lid can be taken as a whole and put onto the chamber. We then add the pH electrodes which have been calibrated prior. The chamber electrode is placed at the back of the lid, and this reads the pH of the chamber buffer and works in conjunction with the external CO2 feed in order to mediate the pH inside the chamber at pH 7.4. The cartridge electrode is smaller and is placed directly inside the cartridge, and this monitors the pH change upon injection of the formulation. After the pH probes, we add the thermocouple, which helps maintain the assay temperature, followed by the tubing to the chamber, with the red line indicating fluid leaving the chamber and the blue line fluid entering the chamber. The system is a closed loop and allows for the Gilson autosampler to remove aliquots of the chamber buffer at predetermined time intervals via the external flow-through valve for offline analysis. The black line is the CO2 line running to the external CO2 source. Before starting an assay, we make sure that the system is equilibrated by looking at the chamber, pH and temperature, as well as the LEDs. Once this is completed, we can inject our sample slowly to ensure proper depot is formed. Once injected, we then click Next on the software, acknowledging that the sample has been injected and that the assay can be left to run. Once the formulation is injected, if there is any precipitation or the formulation is a suspension, for example, this will alter the light pathway between the LEDs and the diodes, causing transmission to decrease. In this example, the formulation is opaque, and we are looking at 4 LED channels individually. Upon injection, the depot blocks channels 1 and 2, seen in green and pink on the graph, causing a decrease in transmission. As the depot starts to migrate away from the injection site, channel 1 in green is no longer obscured and starts to increase once more, whereas channel 3 in purple starts to become obscured. As the formulation migrates, channel 1 and 2 in green and pink recover back up to 100% transmission, and channel 3 and 4 in purple and orange then become obscured. As the formulation starts to reside at the bottom of the cartridge, all of the top 3 channels return to 100% transmission and only channel 4 in orange remains obscured.